In this example of calculating the determinant, another example from section 7.7, we have a 4 by 4 that we need to find the determinant of. And a 4 by 4 would normally be a bit of work, but in fact, if you take a look at row 3, you'll find that we only have one non-zero term. That makes this an ideal candidate for the cofactor matrix minor method, as long as we use row 3 as the row of cofactors that we're going to consider, because we won't need to consider any of the zeros, because those cofactors will all have all be zeros, so there's nothing there to sum up. We only have one cofactor that's non-zero, so this simplifies to a simple formula. But to get the formula, to begin the formula, we need to get the sign right. And to get the sign of the cofactor on 2, we have to use that method that I described in the lecture notes, where we plop down the pattern of the signs, and then we just pick the one that's appropriate for our cofactor. In our case, the only non-zero cofactor is associated with that spot in the matrix, so we start out our determinant with the correct sign, then the correct cofactor, and now we're left with a reduced 3 by 3 matrix instead of a 4 by 4. To find that 3 by 3, we cross out everything in the column and everything in the row associated with our cofactor, and we'd write down the remaining 3 by 3, and that gives us 1, 4, minus 3, minus 1, minus 2, 1, 2, 1, 5. And that's the 3 by 3 that we need to find the determinant of. Once we find this result, we have the determinant of our original matrix. By the way, notice that 17 in the original determinant might have made things look very scary. I did that on purpose because I knew we'd be able to take advantage of this process, and in fact that 17 does not affect the value of the determinant of that matrix. I could have put 5,000 there and it wasn't going to change the result. So we'll now just go about calculating this determinant of the 3 by 3. So we're going to have 3 positive terms associated, or 3 terms that get a positive sign that are associated with those diagonals. So the first diagonal gives us 1 times minus 2 times 5. That's minus 10. Minus 10 is the first term. The next one is minus 1 times minus 3. That's a positive 3. Then we have the last of the diagonals that move down and to the right. We have 2 times 4 times 1, and that's equal to 8. And then we have the 3 negative terms that come from the diagonals in the opposite direction. Whoops. I'll do that again. There we go. Minus 3 times minus 2 times 2. That's 6 times 2, or 12. And then we have the next diagonal, which is 1 times 1 times 1. So we already have the sign taken care of outside that parentheses, so it's plus 1. And then we have the last diagonal, 5 times 4 times minus 1. That's equal to minus 20. So we calculate this determinant as minus 2 times, if we add up these terms, we have minus 10 plus 3 is minus 7, plus 8 is 1, minus 12 plus 1 is 13, minus 20 is minus 7, and that's 1 plus 8 times 2, well, times minus 2, gives us minus 16. And that's our result for the determinant.